chicken rice shop, bukan sekadar nasi ayam.
Hi, we are from CS1115A. We are performing an observation towards one of the restaurants in Raub. This video will be explained about queuing system at the chicken rice shop Raub. If you want to know more about it, stay tuned and open your eyes widely.
Hi, my name is Nurul Syafiqah binti Salman. My matrix number is 2022846356.
Hi, I am Nur Aina Nazifah binti Muhammad Shukri. My matric number is 2022881648.
Hi, my name is Mushida Swani. My matrix number is 202245262.
So, as introduced by Syafiqah just now, our selected restaurant is at the chicken rice shop Raub, located at Raub, and then the operating time is starting from 10 a.m. to 10 p.m. We choose the observation time at 2:45 until 3:45 p.m. And then the number of workers there is 7 workers. Now I will tell you a little bit about the overview of the customer flow process from ordering, serving and payment. After customer enter the restaurant and sit at the available table, the waiter will provide the QR code to be scanned by the customer, as shown in the picture above. After that, in a few minutes, the food will be served by the waiter after they prepare it in the kitchen. The kitchen is shown in the second picture at the below. Lastly, when the food is finished, the customer need to pay the bill at the only counter there.
So, I want to talk about arrival characteristic at the chicken rice shop Raub. The size of calling population is infinite. Population are often assumed to be infinite when the number of potential arrival is large and the probability of any one customer is arriving is low. For the example, if the chicken rice shop serves 4 customer and visitor passing through Raub, the pool of potential customer could be modeled as infinite. The second one is the pattern of the arrival system. The pattern is random and it generally follow a distribution. The third one is the behavior of arrival exits. The behavior is patient customer. Customer may balk if the line appears too long or if there is not enough space to comfortably wait.
Now we move to waiting timeline for the chicken rice shop. The length of the line is unlimited. The queue discipline is first in, first out, FIFO. The customer are generally served in the order they arrive, meaning that first come, first serve.
So we talk about the service facility characteristic at the chicken rice shop Raub. The first one is the number of the channel. The number of the channel is single channel system. The second one is the number of the pace. The number of the pace is multi-pace, which is each activity, ordering, serving and payment is sequential and distinct with different mechanism, website, waiters and payment counter. Each customer is experienced at the pace which is order, wait for service and pay at the counter. And the last one is the number of waiting line is single line. So for the basic configuration system at chicken rice shop Raub have single channel multi-phase system. The diagram above show you how single channel multi-phase system it works. Now I will explain why single channel. A customer interact with only one server or system at a time. Here, this is 3 pace, which is the first pace is ordering pace. Customer place orders through a single digital system via QR code. The second one is serving pace. Each table is served by one waiter at a time. The last pace is payment pace. All customers use the same payment counter to settle their bills. This means there is no parallel servicing for a single customer during any pace. Now I will explain about why multi-pace system. The service process is divided into 3 distinct stages. For the pace 1 is ordering. Customer order their food online. The second pace is serving. Waiters deliver food to the table. And the last pace is payment. Customer pay at the counter. Since customer move through multiple stage sequence, the system is called multi-pace.
Moving forward to the observation result. Before we go to the queuing model, let me tell you what is lambda, mu and s. Lambda is average number of a customer arrive per hour. The mu is average number of a customer in a server or the system that they can serve per hour, and S is the number of a server. Queuing model that we obtain, there is lambda is 9, mu is 33.75 approximately to the 34, and S is 1. From the result obtained, we are going to calculate the average number of a customer in the system, average number of customer in the queue, average time of a customer in the spend in system, average time of a customer waiting in the queue, the utilization factor, and the last one is the percentage of the idle time. For the first one, which is the average number of customer in the system, the formula is L equal to lambda over mu minus lambda. And then we need to insert the value of lambda and mu, which is 9 over 34 minus 9, and then we get 0.36. While for the second one is, the formula for it is LQ equal to lambda square over mu, in the bracket mu minus lambda, and then same goes as the above. We need to enter all the value that we obtain for our observation, and then we will get the answer is 0.0953. Okay, now the third one, we are going to find the average time of a customer spends in the system, and the formula is W equal to 1 over mu minus lambda. We insert the value, and then we got 0.04 hours, but we need to take a look for in the minutes, time by 60, and then we got the answer is approximately to 2.4 minutes. The fourth is the average time of a customer spent in waiting in the queue. The formula is WQ equal to lambda over mu minus mu, in the bracket mu minus lambda. And then the result obtained is 0.653 minutes. The fifth one is the utilization factor. Actually, the utilization factor is a probability of the restaurant will get busy. And the formula is lambda over mu, which is 9 over 34. And then the probability is 0.26. And the last one is the percentage of idle time, which is the restaurant is not busy. We need to minus 1 from the utilization factor that we get, which is 1 minus 0.26, we will get 0.74 times with 100, since we need the answer in a percentage. And then the answer there is 74% that the restaurant will be not busy. After we have done the calculation manually, we are going to prove the calculation by using QM window system that will be explained by Mushidah.
Next, the queuing system by using QM for Windows. First, choose the waiting lines on the left side and click on the M/M/1, which is exponential service time, because our queuing system is single channel. Next, we put on the title, and the cost analysis will remain none. After click the OK button, it will come out with the table and fill the value of lambda and mu. We use hours as a time unit. After that, click the solve button. For the final result, the average server utilization is 0.26, the average number in the queue is 0.1, the average number in the system is 0.36, the average time in the queue is 0.01, the average time in the system is 0.04, and last but not least, the probability in percentage of time system is empty is 0.74. Lastly, the conclusion. The adequacy of servers. First, the number of servers provided is adequate because the customer's waiting time is less than the arrival time. Second, customers are happy with the service because they no need to wait long before being served. What we learn from this project is, first, we understand the real-life queuing systems. Second, the impact of poor server performance. Third, the importance of service and arrival rate.